Hello dear students, I hope you are doing well, and today I will go explain for you a new lesson which is about the continuous of mixture. I explained for in the last video some of the points of mixture. What's mixture? Now I'm going to explain what is the ratio of compounds in a mixture. Before we studied what is the meaning of the ratio of elements in compound. Now we have the ratio of compound in a mixture. Okay, a compound is made of elements in a specific mass ratio. Compound is made of elements in a specific mass ratio. However, the components of a mixture do not need to be mixed in a defined ratio. In the mixture, we don't have these ones like elements. And for example, we have granite is a mixture made of three minerals, which is feldspar, mica, and quartz. Feldspar is pink in color. Mica is black, quartz is colorless. Look at the egg-shaped paperweights in the figure number 3, this one. These three objects are made of granite. They are different colors because their granite is used in each has different ratio of minerals. The pink one is made from granite that has more feldspar than mica or quartz. That's why it is pink. The black one is made from granite that has more mica than the other minerals. The gray one is made from granite that has more quartz than the other minerals. Even though the proportion of the minerals change, this combination of minerals is always a mixture called granite. In this paragraph, I explained what these figure number 3, this is 3 objects are made from granite, but they are different in color because the granite used in each has different ratio of minerals. We can use granite in such a different type of these minerals. Okay, combination and above summarize the difference between mixture and the compound. Here we have what difference between mixture and compounds. Elements, compounds, or both. Compounds made of elements. But in mixture made of elements, compounds, or both. Made in both of them. No change in original properties of components. Change in the original properties of components, because as we said, we can change or breaking down compounds by chemical change. Separated by physical means, they are separated by chemical means. As I said, these components, we can break down these components to the elements by chemical means, formed using any ratio of components, but in compound we say they form using a set ratio of components. Okay, they have the same ratio. We have another thing which is solutions. Solution is a homogeneous mixture of two or more substances uniformly dispersed throughout a single phase. A solution is a mixture that appears to be a single substance. A solution is composed of particles of two or more substances that are distributed evenly among each other. Solutions have the same appearance and properties through the mixture. Solutions have the same appearance and properties. Solutions have the same appearance and properties through the mixture. The process in which particles of the substance separate evenly throughout the mixture is known as dissolving. How we have a beaker, a glass, when this is filling with water, okay, and when we put salt in it, as we said, this salt is dissolving in the water. In the solution, the solute is the substance that is dissolved. The solvent is the substance in which the solute is dissolved. It means this one is solute, dissolved in this solvent, okay? The salt is solute, and the water is solvent. It means the salt is dissolved in the water. This one solute. The solute is the substance that is dissolved. The solvent is the substance in which the solute is dissolved. Okay? A solute must be soluble or able to dissolve. A solute, it means salt is solute, must be soluble or able to dissolve. In the solvent, a substance that is insoluble, if we have some substance that insoluble or unable to dissolve in the water or in any things, forms a mixture that is not solution. When you put something in the something, when they are not mixed together or they are not going to be a solution, this is not a mixture. Or form a mixture is not called a solution, because when you put something in the water or in any solution, they must have solute and solvent. This process is called solution. Salt water in a solution. Salt is soluble, as I said, in water, meaning that salt dissolves in water. This salt I put it in the water is soluble, therefore salt is the solute and water is the solvent. And this is water is what? Solvent. When two liquids or two gases forms a solution, the substance with the greater amount is the solvent. We have examples of solution. You may think that all solutions are liquid because when you put something in it, it must be a solvent and solute. This is a process called solutions. And so we have in fact tap water, tap water and soft drinks, gasoline, and many cleaning supplies are liquid solution. However, solutions may also be gases, such as air. Solutions even may be solid, such as cetyl. Alloys are solid solution of metals, are non-metals dissolved in metals. Brass is an alloy of the metal zinc dissolved in copper. Steel, their elements, is an alloy made of the non-metal carbon and other elements dissolved in iron. This table shows it list for more examples of solution. We have different states in solution: gas in gas, dry air or oxygen in nitrogen. We have something gas in liquid, soft drinks, carbon dioxide in water. We have liquid in gas, moist air, water vapor in air. When you put water in the kettle or expose it to the heat, it's called water vapor in air. Liquid in liquid, antifreeze in cars. You know what's the meaning of antifreeze in cars? Antifreeze. Alcohol in water. Solid in liquid. Salt is a solid. When you put this salt in water, it will be solutions. This is the examples of solution, and please memorize all of these things because it's very important. You must know what's the meaning of states of solution. We have many this self-check. What is an alloy? Please solve this question for me. I will ask you homeworks in meeting, inshallah. Particles in solutions. The particles in a solution are so small that they never settle out. They are also cannot be isolated from the mixture by precipitating or filtering in. When we put salt in water, it will be dissolved and we cannot filter it or taking back the solids. The particles are so small that they do not even scatter light. Both of these two jars in this figure, these two jars in this figure, both of them containing mixture. The mixture of this jar is a table of salt in water. This one, table of salt, we put it in the water, it will be solution. The jar on the right holds a mixture but not a solution. As I said, if something they are mixed together, it is insoluble, it is not dissolved, it doesn't call it solution. Okay, and this is gelatin in water. Gelatin is not dissolved in the water, so when this one's mixture is on the left, however, is a solution, the particles in solutions are so small that they do not scatter light. Therefore, you cannot see the path of light through this solution. If we put this jar here, we see the path of the light through this jar, okay? But in this one, it's contained the gelatin, the particles is so small and they do not scatter light. So we have in this figure number 5, we have these two jars. Also be careful, jar, the dilute solution in the left one contains less solute than the concentration solution in the right. This is contain more solute. As I said, when you put something in the water, it's called a solute, and this is solvent. The water or the liquid is solvent, and the particles we put it in it, it will be solute. So we have concentration of solutions. A measure of the amount of solute dissolved in a solvent is what? Concentration. The amount of a particular substance in a given quantity of mixture or solution. Concentration can be expressed in what? Please memorize these things because it's very important, we need it. A concentration can be expressed in a gram or solute per milliliter of solvent, gram of solute per milliliter of solvent. Concentrated or dilute solutions can be described as being concentrated or dilute. In figure number 5, as we said, both solutions have the same amount of solvent. As we said, the solvent is the same. Then the solution have the same amount of solvent. However, the solution on the left one contains less solute than the solution on the right. The solution on the left is dilute. The solution on the right is concentrated. Is concentrated because the solution of this one is less. The solution on the left, keep in mind that the terms dilute and concentrated do not tell you the amount of solute that is dissolved. The word of dilute and the concentration, they do not give us the amount of the solute that is dissolved. When you put the solute in these two liquids, they do not tell us how the how much the amount of these two solutes. So we have solubility. Another thing, which is solubility, the ability, if we add too much sugar to a glass of lemonade, not all of the sugar can dissolve, okay? Some of it sinks in the bottom. To find the maximum amount of sugar that can dissolve, you will need to know the solubility of sugar. It means solubility of a solute is, because we put sugar in the lemonade glass, we must know the solubility of this sugar. Solubility of a solute is the ability of the solute to dissolve in a solvent at a certain temperature. This figure shows how the solubility, figure number 6, solubility of different solids in water. With the solubility of most solids increase as the temperature gets higher. This is the temperature from 0 to 100. When the temperature gets higher, these types of the solids increase their solubility as the temperature is higher. Gets higher. So more solutes can dissolve at a higher temperature. More of the solids, they are solids, dissolve at a higher temperature. However, some solids, such as this cerium sulfate, are less soluble at higher temperature. Just this one. And please keep focus on this one because I will bring it in the exam. And we have dissolving gas in liquids. Most solids are more soluble in liquids at higher temperature, but gases become less soluble in liquids as the temperature is raised. This is the answer of this one. How does the solubility of gases change with the temperature? As gases become less soluble in the liquid as the temperature is raised. A soft drink goes flat faster when the warm. The gas that is dissolved in the soft drink cannot stay dissolved when the temperature increases, so that the gas escapes and the soft drink becomes flat. Dissolving solids is faster in liquid. Several things affect how fast a solid will dissolve. Look at this figure number 7 to see 3 ways to make a solute dissolve faster. You can see why you will enjoy a glass of lemonade sooner if you stir granulated sugar into the lemonade before adding ice. This is the mixing of the by stirring or shaking causes the solid particles to separate from one another and separate out more quickly among the solvent particles. After this one, we heat this, causing particles to move more quickly, okay? And the solvent can be separated solid particles and separate them out more quickly. And we have a crushing. The solid increases the amount of the container it has with the solvent. The particles of this crushed solute mix with the solvent more quickly. And we have suspension. But before suspension, I forgot something to explain for you. This math break, calculating concentration, how we know the concentration of the sum of these solutions. What is the concentration of solution that has a 35 gram of salt dissolved in 175 ml of water? We have this concentration or this equation. Please memorize it, because as we say, the concentration grams of solute per milliliter of solvent. Replace gram of solute and milliliters of the solvent. We have what? This is gram. 35 grams. We put the grams of solute. This is the gram of solute, 35 gram of salt per 175 ml of water equal to 0.2 gram per milliliter, okay? And please solve these three one for me, okay? We have another things which is suspensions. Have you ever shaken a snow globe? This one. This is the snow globe. If so, you have seen the solid snow particles mixed with the water. As shown here in this figure, the white snow globe contains solid particles inside this one, and we have liquid. It means that solid suspension. Solid particle that will mix with the clear liquid when you shake it up, but the particles will soon fall to the bottom when the globe is at rest. When we shake this one, we see the particles, solid particles inside the water, clear water. But when the snow globes at rest, this snow solids will be fall to the bottom of the snow globes. And this mixture is called suspension. A suspension is a mixture in which particles of a material are dispersed throughout a liquid or gas, dispersed of some particles throughout a liquid or gas, but are large enough that they settle out. The particles and the suspensions are large enough to scatter or block light. The particles are also too large to stay mixed without being stirred or shaken. Because as we said, before we shake this one, if the snow globe is at rest, this solid particles will be found at the bottom of the globe. But when we shake these things, allowed to the particles will settle out as they do not in a snow globe. A suspension can be separated by passing it through a filter, so the liquid or gas passes through the filter. In the suspension, we can pass these particles through the filter, but the solid particles are large enough to be trapped by the filter. But sometimes we can pass the gases through the filter, but the solid ones may be sometimes large enough to be separated by the filter. We have colloids. Some mixtures have properties between those of the solution and suspension. These mixtures are known as colloids. Colloid is a mixture in which the particles are dispersed throughout but are not heavy enough to settle out. The particles in a colloid are relatively small and are fairly well mixed. You might be surprised at the number of the colloids you see each day. Milk, mayonnaise, and stick and deodorant, even the gelatin and the whipped cream in the figure number 9 are colloids. This one. The particles in the colloid are much smaller than the particle in the suspension because, as I said, the particle of the suspension may be sometimes large enough to be filtered by filter paper. But the particles of the colloid are much smaller than it. However, the particles are large enough to scatter light. A colloid cannot be separated by filtration because they are too small. The particles are small enough to pass through a filter. This dessert includes two tasty Examples of colloids: fruity gelatin and whipped cream. How can the particle of the suspension be separated? Answer this question, please. How can particle of the suspension can be separated? I explain it for you. And we have what? We have a summary. A mixture is a combination of two or more substances, each of which keeps its own characteristics. Mixture can be separated by physical means such as filtration and evaporation. A solution is a mixture that appears to be a single substance but is composed of a solute dissolved in solvent. Solutions do not precipitate, nor can be filtered, and do not scatter light. Concentration is a measure of the amount of the solid dissolved in water. We can measure the amount of the solid dissolved in the solvent. Concentration. The solubility of a solute is the ability of the solute to dissolve in the solvent. Suspension are mixtures that contain particles large enough to settle out or be filtered and to block or scatter light. Colloids are mixtures that contain particles that are too small to settle out. It's opposite to the suspension, too small to settle out. They are large enough to settle out or be filtered but are large enough to scatter light. And this one be filtered and to block or scatter light. And you have homework key terms. This one. Homework for you. Homework. Thank you, students. I hope you get benefits from this video.